I'm glad you told me after I
She'll
said
be like, oh, we got the phone.
Four asses.
All right, let's do that bonus question right here. Number 1.
The same exact question?
Yep. Form of a hydrate, barium chloride, BaClXH2O. Okay.
Oh, the one up low.
Okay. We're just about to find X, right? 1.936 grams of this compound. So we've got 1.936 grams of BaCl.2.H2O. Okay, gives us 1.864 grams of barium sulfate on treatment with sulfuric acid. Calculate X. Okay. So this doesn't matter too much, but somebody took this equation and did this reaction. Okay. Okay, double displacement. That's going to be a solid precipitate. Okay, so that will be something you can easily separate and measure.
So we have to do a Gauss equation?
No.
Okay.
Just doesn't matter if you do this or not. Okay. All right, so the point is, though, that this barium and this barium have to be the same, right? Okay, so conservation of mass says start with this, whatever you do to it, this barium is still this barium, okay? These are the same barium atoms that we had up here. These are the same barium atoms that we had right here, okay? They go together. All right, so we can take that amount of barium sulfate, figure out how much barium we had, okay? From that, we can figure out how much chloride we had, because the barium and the chlorine are in a 2-to-1 mole ratio. Okay? And then from that, we can figure out how much water was there originally. Okay? How do you what?
Like just the equation.
Just a double displacement. They said they treated it with sulfuric acid, so I just wrote barium chloride plus sulfuric acid and look at it in minutes. 2 compounds is going to be a double displacement. You ought to be able to do that. We did that last year, right?
Sure ought to be able
We
to
did
do
Gauss
that.
equation.
Yes, we did that.
We did that.
We did that.
Especially when we're
Yeah, I just know the formula first.
But you didn't have to know that to answer the question. I'm just trying to explain to you what's going on. That's irrelevant to answer the question. Okay? It's not needed to know. All right? To answer the question, you just need to recognize that we had a before and an after some kind of chemical reaction or physical process. What we did in our demonstration was the physical driving off of water. And we had a before and we had an after, right? Here they're doing a chemical reaction, but they got a before and they got an after, okay? The barium before and the barium after have to be the same thing. In our particular reaction, we had a salt before, magnesium sulfate before, and magnesium sulfate after, okay? It has to be the same thing. Conservation of mass, nothing vanishes, right? Okay, so you don't have to know that, all right? All right, raise your hand.
Is barium also the same because it's a 1-to-1 ratio?
That's what we just said. Barium is barium. Yes, makes the barium before and the barium after be the same thing.
The 1-to-1 ratio is against it. Is that the
Because
same
of
thing?
conservation of mass, yes.
Okay.
You balance equations because of all conservation of mass. That's why you balance equations. All right, so how much barium do we have? Well, first we got to convert to moles before we can figure that out. So 1 mole of barium sulfate is some number of grams, figure that out in a minute, okay?
33.39.
How much?
I got 33.4.
Well, I got 39.
39.
I was on the right track.
Right, then there's gonna be, for every mole of barium sulfate, there's a mole of barium cations in there, okay? All right, so we can get that number. What is that number?
137.33.
No,
Oh, wait, 1 gram of, is it, oh, 1 gram of barium?
I'm doing this math problem right here.
Oh.
So it's always on.
I got 7.988 times 10 to the negative 30.
Why is it barium 2 plus?
Because that's an ionic compound, right?
Yes,
Doesn't really matter, but that's pretty technical. So,
okay.
we're trying to figure out how much barium is in that much barium sulfate. The barium is going to be in the form of 2 plus. Doesn't change the mass because electrons don't weigh enough matter.
Is that a 0.3? Is that a 0.3 number?
Okay, if you've got that many moles of barium in the compound, okay, you're going to have 2 moles of chloride for every 1 mole of barium. Because this is a 2-to-1 ratio, right? Okay. So that would give us 1.6 to the negative second. Check my math.
We got 0.0159.
Yeah, that's what I got.
1.6 times 10 to the negative second.
Oh, great.
Could we just write it like that too? If that's what it is? I don't know, there's no
It's the
decimal.
same number.
Okay.
It's the same number. Okay. It's the same number.
Miss Carol, I'm gonna ask a question.
Oh,
So, just get prepared.
So we have that many moles of barium, this many moles of chloride, and then original compound. Okay. All right. So now we're going to figure out how much water we would have had. Okay.
Of course.
All right. So we're going to take the barium and convert to grams. We're going to take the chloride and convert to grams. Somebody who knows how to work a calculator doesn't get confused by scientific notation.
Yeah, well,
Just tell me the answer.
I'm not something.
All right, I got 1.10.
This one?
Yes, 1.10. And then for the
How
next
about give
one,
me another digit or two?
oh, well, I don't know where it's.
Just
Wait,
stick with that.
wait,
I got 1.097266.
yeah.
We'll just go 1.1, that's fine. All right, what about the next one? Is it not written on your paper?
It's about to be.
Why is it not already?
I got
Because you're going with.
0.5672. I don't know scientific.
Wait, what?
Yeah, 1.6172 times. That's just what I got in this one.
Okay, so this is how many grams of barium, grams of chloride were in this original hydrate.
Okay, so then you just add them together and like.
Subtract, we're talking about how much water you have.
Oh. Yeah. Well.
So if you started with 1.936 grams of the whole thing, you subtract 1.1 grams of barium and 0.567 grams of chloride, that leaves you with some number of grams of water. So what was that?
0.269.
0.269, okay. All right. 0.269 grams of water is how many moles? Well, a mole is 1802 grams. What's that? Just read it off the screen.
0.01492 seconds of 0.0.
Okay. So, we need a ratio of water, barium chloride.
16 to 1802. Okay, there we go. We got something?
This number divided by this number is very, very, very close to 2, right?
Wait, what?
Wait, Why are we having to divide?
You have to get the mole ratio to get
Is it
the
because like
x.
we're dividing by the smallest one?
Divided by the smallest. We're looking for x, correct? So how do you get a mole ratio? You find the moles of two things and divide one by the smaller one. Ratio. This is the smaller value, the barium chloride. It's this many moles. And this many moles of water. If you divide, you get 2.
I got you.
Type it in. You ain't got it. Type it in. You ain't got it. Type it in.
I'm lost. I really don't like you. Why are we having to divide extra by BA?
Because you're looking for the x, the mole ratio between barium chloride and water.
So
It is
very-
0.5. Ooh, that's what I got. I got 0.53, Mr.
You
Kelly.
did it backwards, just like you did on the second question on your quiz.
So is it?
Ooh, Mr. Kelly.
Barium
First of all, I did not do it backwards.
Divided by the
I
smallest.
had-
You did it backwards last
Okay,
year.
wait a
We had an entire
minute.
class conversation about fractions,
Wait a minute.
and you divide everything backwards.
Mr. Kelly, wait
How
a
All of
minute.
your answers are inverses.
Mr. Kelly, look, on this quiz, I
Take the
did.
big number and divide it by the small number, and you will get a whole number answer. We went on this last year, Grant, for like 30 minutes one day.
Okay,
Just for you.
wait. Okay,
If you divide small numbers by big numbers, you get decimal answers.
okay, so
like you
small
just got.
numbers by big numbers.
Take the big number and divide it by the small number, and you will get a number that's bigger than
So
1.
on this test, I should have took the big number and divided it by the small number.
Yes, because the steps to finding a molecular formula say you
Have
do
to be
that.
whole.
So then
So they
it's
have to
one,
be whole.
it's 1.86, so then we just
Two.
add that to.
Yep,
So what dictates
This
close
is
enough
crazy.
to 2?
close enough to 2.
Bigger than 5?
Lab, it's gotta be something. It can't be a decimal.
Okay.
This is lab stuff, right? Can't be a decimal. It's gotta be the whole number. Because there's no such thing as barium chloride 1.89 water. That's not a thing, right? So when we go to a lab and do an experiment, and we get 1.89 for something that we know is supposed to be a whole number, 2, right?
I don't know why I'm stuck. Like, I don't know why I'm stuck right
I'm
here.
always
There.
Where are you stuck at?
I'm stuck at the last step, dividing 0.0.
Finding an empirical formula. That's what you do. The last step of finding any empirical formula is divide each mole value by the smallest value, right?
Yes, it's just set up here. I didn't look at the 1.60 and realize that was.
You take this number and divide it into this one and this one, you get 2 and 2.
I see that. I wasn't looking
Rounded,
at that. until it was
rounded,
small.
right? This will be exactly 2.
Yeah.
We already knew that though, right? Because we're not looking for that. So we're not looking for that 2. But just to show it, you divide it into this number, you get exactly 2. We already knew that. So that-
I see it now. I write it on my paper.
Divide it into this number, you get a number that obviously rounds to 2. So X is
I wasn't looking at the It took me a
What
minute.
are you gonna prove me wrong
Plus
about?
1.01.
Division is.
Oh, yeah, on this little division, yes.
You're not gonna prove me wrong.
Well,
on
we want to
division.
do something.
So 14.0, and you said it's about
Or well,
70. So I do 70 divided by
It was
14.03.
You get 5, right? If you flip it over, you get 0.2.
But, Mr. Carroll, wait a minute, wait a
Math.
minute.
So
Wait a
much
minute.
good, it's math.
Because
Sorry.
technically, it could have still worked. I just multiplied, I did it by 10 instead of by 5.
It's just random
Mr. Carroll, can I please show you,
No, I'm not.
please? Oh my God.
Kato, do you have faith in us that we'll pass this exam? Like, be honest, because like, you look a little like, you look distressed.
Yeah, it's normal every year. Blows my mind. Yep.
So,
Y'all's ability to do math never surprises me and it never impresses me. Either one.
I'm
I've been saying that for about, well over 10 years I've been saying that.
So I'm sure it's really simple on the B part of the library thing that I got wrong. I'm sure it's really simple why I got it wrong, but I was
Talking about
really,
scandium.
yeah, I was really
I thought it was
confident whatever my answer was.
Dude, I did too until like.
No, Kato, on this test, you giving us a clear periodic table, because that one back there, it was too blurry. It was way too blurry.
You got the job
Oh,
done.
yeah, I could barely.
It was too blurry.
You got the job done. You can see the numbers.
Oh, wait.
Scandium, right?
Yeah.
Okay.
Yes.
Easiest stable ion, always one right answer for any metal. Any metal. Always one right answer for a stable ion is to take out the valence electron. So this should have been the first answer that everybody got.
Yeah, I got that one.
Okay?
Oh, wait.
Yeah,
They got the two valence electrons.
That's where I went wrong. I think I took away the
The
three.
next one is to take that long little. Shh, all right, pay attention. The next obvious choice is to take away this long little straggler right there, okay? Scandium 3+. Some people put negative anions for a metal, that's never gonna be a thing.
I thought it was SE.
Never gonna be a
It was
thing.
not clear on here.
Tell me these, no, I would have made it. Tell me those those look like SE, Kato. Come on now. He's filming and I'm over here just. Tell me that, I need a clear periodic table. They look the same, Kato. Yes, they do. Yes, you know they do. So on this test, I'm gonna go up there and I'm giving me a periodic table.
She says she confused it with selenium.
Cause it looked like SE on a thing.
Even though, did it not say on the paper, did it not say on the paper number 21? Did it not say that on the paper? Atomic number of 21, how about that? 21.
That's not.
That's just like your feeling. This is like whoever, like just imagine some science just watching this like.
Ain't nobody watching this.
Okay, let me show you this. Let me show you exactly how you divide this thing.
Look, some shrink doing some kind of case study on it.
Look, you got 14.03 divided by 70, right? You get 0.200. You multiply so you get a whole number, right? Then you get 1. So the thing you multiply by will be the thing that went right there.
Because you took away 2 from.
Hold it on how to do it, whatever you gotta do.
I'm telling you, it gives you the right answer.
Why are you saying?
It gives you the right answer.
Oh, my goodness.
Hey, one more thing.
Hey, would there be a bonus? Or several, please?
One more thing.
There'll be something, yeah.
Right, you're gonna miss this one. You're gonna be like, dang, them girls got on my nerves, but I miss it.
I'm not a counselor.
That's what you're gonna say.
All right, let's talk just a minute about the test Thursday. She asked about a bonus, okay? Normally what I do on unit tests is we grade it what we call AP style, which means we don't grade it out of 100. But as we've said before, 75 is the mark, right? That we're trying to reach on AP exam, correct? So I hold you to a little higher standard during the year because unit tests are easier than the real thing because the questions aren't mixed up. Like every question on this unit test, hang on just a minute, is about atomic structure and periodicity, so you know what it's about. So I usually grade it out of something less than 100, usually like 90 or something. Which means if you get all the questions right, you can make like 111 or something like
So it's kind of scale hat. What's that?
It's kind of like standard, yeah.
Hey, we out of here. She was trying to fire us up yesterday. Light us on something.
Y'all need to get there on time today. Don't come after me.
Okay, so number 8, that's why I did number 8. When I got that 0.78.
I'm wearing a Barbie outfit.
Number 8. That's how I did it.
Redneck, but like cowboy.
So I had like, where do I go from there?
Quarter to 3/4.
Wait.
25.75.
Oh,
That's the average.
oh yeah.
The average is quarter of the way. The other number.
Well, the answer says 10.
Right, 7 times.
But I don't get how we get it. Whenever I get it, like I get x equals 0.78. So
Which
is it
is
just
75.
Oh.
This isn't math class, this is chemistry class.
Oh, right. Oh, right.
Think a little bit.
She didn't think about the
0.78 is close enough to 0.75.
No, I was thinking I had to like distribute it. So
question.
it's like
Would there
35
be anything
and
about the like pure substances on this test? We talked about at the very beginning, or like there's like a mixture of like
Sure.
potassium or whatever, and
Yeah,
it
you
was
could do
like
something like that.
which one was the purest, or like
Could be.
I hate those questions.
Could be.
I hate any damn question. If I'm being rude.
Practice, practice, practice.
Yeah, I tried doing Khan. I did Khan. It's so weird. I did the Khan Academy like the night before the quiz, and then boom comes quiz. Like I did like the quizzes like 3 times in a row, and now I'm fine. And then here comes quiz. Boom. Just.
Y'all stress yourself out.
Well, I'm sorry, I don't. Learn that way.
Gotta take a deep breath, you know.
That's a dead zone.
Why you just stretch yourself out? Oh, you're very smart. Stretch yourself out.
I'm listening to the whole good.
I don't know what I'm doing. I'm gonna.
You knew what you were doing. You just said to me.
They cut the camera off before one of these people do something.
Oh, just like when we all
They're drawing a poster.
Really?
I know, no, I don't know.